So glad to have everyone here. Definitely a good turnout tonight and a lot of new people. So this, for everyone who hasn't been, we meet every month on the third Tuesday, and we try to do things with .NET in mind, but it's really more of a technology user group. Wizards are a technology company, and we do partner with Microsoft, but we're not tied at the hip. So we do things that are custom for clients. A lot of times we are working on different things day in, day out. Project-based work, so mostly websites, a lot of custom Internet of Things, mobile apps, really anything that customers dream up and they're willing to pay for. So Docker is one that internally we haven't really done a ton with, so I'm hopeful that this could inspire some ideas for potential for use. We do a lot with Microsoft Azure, and that's one direction that they're definitely going in with Docker and Kubernetes, which is really just a related Docker management software package. So for me, Docker just makes life easy for teams. And I think that's part of why it's so popular. It's a really simple concept, but it's one of those things that you really have to see it in use to get your mind around it. You see all these pictures of a whale carrying containers, and that's kind of the idea. It's containers for things you want to ship to other places, whether that be a cloud environment like Azure or Amazon, or just another developer's machine. So for me personally, when I first got into Docker, it was to use MongoDB. MongoDB is one of those things that can be quite simple to set up, or it can be a little complicated if you run into an error. And when I was in college, I had to do a capstone project, and part of that was MongoDB. We were doing something that had a document database with some search functionality, and some of the other people on my team had trouble getting it set up. So we didn't end up sticking with Docker, but this was an area where I really delved into to see how I could get MongoDB up and running in a consistent way on all of our machines for testing purposes, and do things like test data and mocking data. And there's a lot of room for growth there, but you see, looking at this page, you've got to pick out a version, an OS, a package, and there's a lot of potential differences there. So when you've got people working on MacBooks, Windows, Linux, this is a really great way to use Docker, and I'll get into more details on this, but to isolate your dependencies. SQL Server, more from the .NET side, they actually have Docker packages. So just like MongoDB or SQLite, you can actually isolate things like SQL Server and put them really close to your application. So you don't have to have all of the configuration that goes into running a local SQL Server. There's still licensing concerns, of course, but that's just a room that Microsoft is really interested in getting more into. So taking a step back from Docker, more generally, I want to talk about what a container actually is. And I got this from Docker's website, just a real basic what container page. And at its most basic level, it's a standard unit of software. So kind of like how a molecule has atoms in it, it has electrons, it has protons, neutrons, all that fun stuff, and electromagnetic fields and ways they connect to each other. That's what a container really is. It's just a standard unit, the smallest way you can encapsulate something. And it virtualizes things. So kind of like a VM, how you might have an isolated operating system, you can do that with Docker. Now you can also do some really cool things like sharing your kernel across containers. So you could have, kind of like if you might have a database server and a web server, and they're both running Windows, but you kind of want them to be on their own. You can do that, but you can have some efficiencies. Docker has the ability to actually share the Windows kernel across containers, which is a really cool feature that you don't get with VMs. And it reduces a lot of your overhead. You can share those virtualized resources, like I said. And then also another big advantage here, and this is really, I think, why it's probably the most popular as of late with the cloud, is you can take old applications that aren't really designed for cloud environments or for scaling out, and you can put them into a Docker series, a Docker Swarm or a Docker container, just isolated, and then push them up to the cloud with very little effort. Now, I say very little effort. There's a lot of learning curve to this. There's still a lot of, if you're not used to working with a CLI, you're not used to a lot of the IT and sysadmin type tasks that go along with deployments and DevOps, it will be a learning curve, and it still is for me. So this is from a Pluralsight course by a guy named Wes Higby, and it's just called Getting Started with Docker on Windows. And this I thought was a really good way of illustrating how Docker works and really how container systems work in general. So if you want to install an application on a computer, say that MongoDB example I gave, you're going to go on the internet and find something, see up here, and that's its own little box because the internet's not on your computer. You have to go out and get something. You're going to download it, and then you're going to take that image or installer or package, whatever you want to call that, and you're going to install it on your computer. And then that's going to run on your memory with your CPUs and get all the hardware specific stuff in there. Whereas with Docker, you have a centralized place. Instead of going to Google and worrying about, is this a legitimate download link? Is this a virus? Is this the right version I'm looking for? You go to the Docker Hub. And then kind of like GitHub, how you might do a git pull or a clone, you're going to pull with Docker. That's downloading your application you've chosen. And then that image, you'll see the word image referred to a lot in documentation and code. That image is then used to generate a container. It's the instructions you need to get that application up and running on your machine. And then once you have that container, you can either have it running or not running, kind of like how you have a list of applications in your start menu. Those things are installed and they're available for you to use. But once you run the container, then you actually have some stuff going on with the Docker engine. Some terminology, a little bit of this I just covered, but a container is standardized unit of software. It's something that standardizes your application so that you have a common platform to work with and a common communication scheme between them. You have images, which are really just the layers that define your containers. Those are the things that tell you how to build the container. It tells your computer what it's made of. The Docker file is kind of a step further from that. It's the instructions to build the image, which are then going to build the container. So you go in a chronological way with this. And then the Docker ignore is kind of similar to a git ignore, how it's going to tell you what not to commit to source control whenever you push up to the server. This is going to tell you what not to commit to your Docker images. It's going to tell the Docker file, if you copy an entire directory with a .NET application, you can take things like the bin folder or the object folder, or anything like a media library, something you don't want. You can then tell it in the Docker ignore. Very simply, just explicitly write /bin /object, and that's it. You can get a little more complex with that with wildcards, but that's pretty much the basic idea. So this here is a good example of a basic Docker file. This is one that they actually have on the Docker docs. And these are 4 things that you might do in pretty much every Docker file you're going to write or see. From is the base image. So it's this idea that you have a base something that you're building something else on top of. In this case, it's Ubuntu. A lot of times you may see Alpine. And now Windows actually has Windows Core, Windows Server Core, which is an image. It's about 4 gigs in size, but still that's relatively small compared to VMs. And they have other things like Windows Server Nano, which is even smaller. Copy. So this is going to take code that you have somewhere on your machine, and it's going to copy that into the app folder inside of a container. Run is going to tell it to run something from inside the container. So make is the build command they're using here, and then /app. This is all kind of very Linuxy terminology, if that's a word I could use. And then cmd is telling it, once that command was built, this is what you want it to do with that application. You want to tell it, okay, I'm going to use the Python interpreter to run a Python application. So this is just a very basic way of defining a manifest, you could say, or what you want it to do whenever you build your images. So I'm just going to jump right in here with a couple examples. And these are pretty basic, traditional Linux Docker examples. So let me get this over here. That should work. Minimize this, or multiple windows going on here. Next. And does anyone here have any practical experience with Docker or used it? Yeah. That's awesome. I know it's one of those things for me, at least, it was kind of hard to figure out why are people using it when I first started to see how popular it was getting. I didn't see the practical use cases up front, but once you start looking at it from that analogy of it's kind of like when you get software online, that you could actually just run applications that you run every day on your computer using it. I think that's what makes it really unique and cool. Okay, so now that I've got some windows open here, I'll bring one more thing over there. So I'm going to make this a lot bigger. And hopefully that contrast is good. I know it's a weird color. But I'm going to, where did I put my PowerPoint? Sorry for the little back and forth here. Okay. So this is one of the most basic things you can do. You can tell it that you want to run something, which is an image. And then IT is interactive. So this is saying I'm going to want to interact with this image almost like you would if you were interacting directly with a Python shell or your shell in general. And then I'm going to base it on the Alpine image, which is a super lightweight version of Linux. And then I'm going to, if you've probably seen from Linux, I'm going to run the shell, the born again shell. And in here, I can actually do things as if I'm in that Linux machine. And it's a full-blown machine. I can put more things on there. I can run tasks. And where this could come in handy is I know right now I'm on a Mac, but the Mac is a little different than Linux. It has a lot in common, but if I wanted a truly pure Linux environment on a very specific version of Linux, whether it's Debian or Red Hat, things like that, this would be a great way for me to recreate that. And then you'll also notice this Docker run command that I did, I don't actually have Alpine locally. I happen to because I did the task earlier, but you don't have to tell it to pull every time. Previously, I'd shown that you could do a Docker pull to get applications. If it's something that's well known in the Docker hub, it's publicly available, it'll go then try and find that from the registry. Or if you have what I'm going to talk about at the end, if you have a local registry or a private registry of Docker containers, it can also check those as well. And it'll implicitly know that you have these things locally. It'll start searching for them if it doesn't find it. So I'm going to do one that's a little more complex, but still fairly straightforward.
Quick question.
Yeah.
Will it keep track of what you're doing there, or if you want to use this to knock out your Docker files, you can keep track of the command secure?
Yeah, and that's a common thing I know with CLIs. Visual Studio Code is really helpful in this way because it's got a built-in terminal, so you could quickly be going back and forth from a text file to the terminal. But this isn't going to save out. You could echo it into a Docker file, which is basically just saying you're going to pipe the output. And the syntax is different on Windows, which I'll show that in a second, but file.txt or Docker file. And then it would put that, in this case, in my home directory. But then you wouldn't really be seeing that. That's kind of just a quick and dirty way of putting it in a file. That's not going to run and show you what kind of things you're doing. So here. So this one, error response. Okay, so I need to do a little cleanup here. And I have some containers that are running. Container, I'm going to stop them. And the syntax here is you're going to get all the containers, and then Q is telling it just to get the GUIDs of the containers. So I haven't really covered that yet. Once that finishes running there. This next example I've got here is just running a static website. So it's one of the Docker samples images. And these are ones that Docker provides to get you started quickly and show you some things that you can do with their product. It is called static site. It gives you the opportunity to put in some parameters like an author name, which then uses as an environment variable inside the little application that's going to spin up. It's going to name it so that it has something unique on your computer so you know how to look it up and find out what the port numbers are. And then -P here is going to tell it to just assign whatever port number it can, whatever port number is available. Container name is already in use. Oh. So I might end up having to skip over this one if this doesn't do much soon. No. Image ls dash something like that. Yeah. So if I've got this already running, I may be able to tell you this, but this is how, once I've done that, it's going to spin up and it's going to have to generate a random port number. A lot of times you'll see things like this with Node Express apps where it's got a localhost 5000 or something. And if you have something else that you've already spun up that has a competing port number, you have an issue there. Internally on these containers, they are using something like localhost 5000 or localhost 5001, but from the outside, you can then have a separate port that you're translating inside. So it looks like I can't access that one. So what I'll show you now is one that's a little more cool and actually should work. This one is a voting app, and this is one of the common examples you see when you first get into Docker. It's based on Python, which I've never used Python personally to make web apps, but you can. They have a lot of cool things that you can do with that. So let me get this here. Example voting app. Some of the syntax is a little different here because I did this on Windows initially. So Node is now a manager. So the point of this example is to show you how you can use a web application with scaling out with concurrency. In this case, we're using what's called Docker Swarm, which is a cool feature they've enabled so that you can take your Docker images that you have and then scale those out without having to do a lot of other work from the application level. Now, not just any application is going to work this way. It has to be a stateless application, not something that's using session to store information about the users or about the session, basically. So if you hit any web server running that application, it should be able to process the request. And that's a very basic kind of web concept of REST, representational state transfer, being RESTful. So in this case here, I've cloned down something that has a Docker file already in it, and that stuff's already been defined for me. This can get pretty complex if you're having to define all these out, but it's cool because it's scripted, and you can then go back and look at it, as opposed to in a more of a systems approach like a VM, you're going to have to go and set these things up and observe them in a file system in a graphical way. So the last request I've got here, I'm going to take this stack that I put together, and I'm kind of rushing through this more just to show the concept of what it can do. So it's given me some information. I've got these port numbers and a number of replicas. And the way I'm going to access this is from my local host. Let me get the port number here. I believe it's the 5000 port number. So I'm going to drag Firefox over there. And hopefully this is still on the screen. But localhost port 5000. So this is the little application that spun up, and you'll see at the bottom, it's got a container ID on it. Not every time I refresh the page, but see right now it's the same. But the second time I refreshed, it switched containers. So there's this kind of trade-off where it's load balancing between the two servers. You could spread this out to as many replicas as you want, and especially in an application like this where it's stateless, like I mentioned, you could have thousands if it were really a huge application. That would be a little hard to manage at some point. You run out of resources. But the point is that if you had enough people hitting this at one time, you may want to scale out. It could be advantageous. So I'm going to vote in this system. I may then change my vote, do things like that. And then the other service that's on a separate part of the stack is going to tell me the answers to what the votes are saying. I could then, in a private window on this other screen, which isn't showing over there, go in and vote again, and you'll see it updated in real time. I can change the vote, and so on. And this is all something that the application wasn't necessarily developed to run in a way that's scalable. It was just developed to do a simple job. But then Docker handles the concurrency, the load balancing of saying, okay, at this point, I'm going to switch over to this application because I got 2 hits in a second, things like that. You can have different, whether it's round robin or weighted approaches, things like that. You can get pretty deep into that stuff very quickly. So let's see if I go back to the PowerPoint. There we go. So we've just done these 3 Docker examples for Linux. There's also a new thing, and I say new, it's not really that new, but Docker for Windows. And the distinction here is that these containers are actually developed in partnership with Microsoft and the platform, the Docker engine. They have a distinct version of Docker for that. And you can switch back and forth. So on a Windows machine, you can do traditional Docker for Linux. But on a Linux or Mac machine, you can't do Docker for Windows. So it's a unique thing. It's really targeting things like Windows Server and very recent versions of Windows 10. There are a lot of compatibility issues, so you want to make sure you're on the latest versions of Windows whenever possible. But you'll see here, this is the Nano server. So this is if you're doing things with IIS or with Windows servers type technologies, you can actually run a full-blown Windows server. So I'm going to slide around here. This is a Windows VM I've got running, Windows Server 2019, so a very recent version of Windows. And I'm going to pull from Microsoft's container registry, MCR, Windows Nano server, and I'll put it on port 1809, or version 1809, sorry, not port. Manifest not found. Yeah, and these are the kind of errors you have to get used to that don't give a ton of details. And I think I may have actually already pulled this earlier, so I'm going to try running it. But essentially what it does is it gives me a command line, a CMD, that if I were to push this off to a Linux machine, I could then have a full-blown Windows command line and be able to use things that you wouldn't normally have access to. Now, of course, you have PowerShell, but the use cases for this are if you have legacy applications, things that maybe are running specific Windows syntax that you can't afford to convert them or migrate them to a newer technology. Windows/Nano server 1809 CMD.
I'm going to ask a really stupid question, but is there any type is there error handling for Docker that you can do? I mean, what would that look like?
Well, there's 2 different levels to that. I mean, you have your application level of it, okay, which you're still going to need that depending on what type of application you're making. But from the Docker standpoint, they have several Docker management software packages. I haven't gotten too deep into that. And if you're using something like Azure, it's going to have its own application auditing that it can offer you with instrumentation and logging. But I believe they also have some offerings for container errors and things that are, that would be kind of in the realm of CI, continuous integration, continuous deployment, where you have some sort of a build server, and it's going to tell you if there's a problem building your Docker images.
Yeah.
And they even have the ability to use Docker images to build .NET applications. And unfortunately, that's actually an area that I wanted to get much deeper into. I have one example that kind of works, but it just, there's a lot of dependencies going on there for sure. And you have to be on very recent versions of everything. So this actually did end up running, but this is, as you can see, I'm running basically a command line, a Windows command line. So not PowerShell, I am technically in PowerShell, but this is CMD. In this particular example, this is a Windows image, so I wouldn't be able to run this exact example on Linux, but the concept is that they have options for this, where you could get this onto a Linux machine and then be able to be using something like that for your build servers. You could be doing MS Build, .NET, NuGet packages, and doing that from a context other than just a Windows server. So it frees you up from the hardware standpoint to do more with your CI pipelines and things of that nature. The other example here, this is not on the screen at the moment, but this album viewer, it was a really cool looking example, but I wasn't able to get that one to work really. So you have these ideas of dynamic applications. And this is more what I was getting into, where it can actually build things like JavaScript on the front end or .NET on the back end. It can actually compile your C#. It can run tests, and you can do that kind of in a hybrid approach with the Docker containers, where you spin up temporary Docker containers to handle those build tasks, and then they go away, and then your web server remains with the database. So you can really flesh this out to be a pretty complex setup. And the advantages there, of course, are when you're getting into more of an automated system, a CI kind of pipeline. Now, for those who haven't done a ton of CLI stuff, this can be really intimidating, especially coming from a world of Visual Studio exclusively, having a GUI for everything. And so they have implemented in .NET Core and even in legacy.NET the ability to add Docker support. This is what it looks like in .NET Core. So if you have a basic ASP.NET Core MVC web app or API, empty web app, whatever your version is that you're starting with, you can add Docker support either when you first create it, when you're in that templating mode in Visual Studio, or here you can right click on the project and then add Docker support that way. And it's going to add in a separate project with a Docker file in it. It's going to create a standard Docker ignore, which has things like the bin and object folder. And it creates a couple other assets, like it updates your web config and it updates your csproj and launch settings.json and stuff like that. So it does a lot of the hard work for you up front. And then I have here an example where this is what it looks like when you're first creating an ASP.NET Core application. So you can either do it here, or I've already shown you the other one, so we'll see what it looks like here. Okay. And this is in real time. So you've got the web application, and then in this case here, you've just got a Docker file. And then if you were to have a Docker ignore, it would be nested under this, just like you might see with code behind with ASPX and web forms, or with these CS files. You've got this little drop-down. It's kind of a similar look to that. So it knows that they're related things. Now, if I add another web app to this project, say I have some other program that is a legacy, I would call it a legacy one. I'm going to go back to .NET 3.5. Oh wow, I only have these. Well, I'm just going to go 4.5 then. It's a web forms application. You can see they've got a similar thing here, enable Docker Compose support. So this one's a little different. .NET Core is obviously more cross-platform. They've made that more to run on Linux without even having to worry about Docker. So it's not really, in my opinion, as advantageous with .NET Core. You still have the CI, CD kind of pipeline benefits if you're going for that. But here, I'll let this load. And you'll see it looks a little bit different than the .NET Core one did. And this is more, in my opinion, what you're probably going to see more of if you're trying to migrate a legacy .NET application, something that doesn't work in a cloud setting for whatever reason, and you need it to work in a cloud setting, and you can't afford to refactor it. Okay, so this is that separate project I was talking about. It's still loading, but you've got a Docker Compose project here. And that's essentially another way, another option of telling it how to build the images. So if you're still using a Docker file, Docker Compose is just a different syntax for that. And it does a couple other things for you. But in essence, from what I've seen, it's just kind of phrased differently. It's a different way of looking at it. Once this finishes loading, see what else we got here. Okay, that did load. So you'll see it's a YAML file. This is kind of similar to JSON. I think they just thought YAML was a cooler name. It's indentation based. So it's, you go in here, you've got some basic definitions in here. Like there's an environment variable for the Docker registry, and then web application 2. This is basically telling it the first part of the name represents what the Docker registry is. And I'm gonna get into that with the next example, but typically it's just the Docker Hub. But in Azure, you can create your own registry. In AWS, you can create a registry, or you can create one locally. Just like people would use either GitHub or Bitbucket or GitLab even. Same concept as those. Down here, we've got our Docker file, and this one has that Docker ignore I was talking about. So let me see if I can make this any bigger, because that is pretty tiny. But it's very similar to a git ignore. You've got wildcard syntax. It's just saying, okay, I've got these 2 little folders in here that are just for temporary kind of build output. So I don't want you to deal with those, just ignore those. And then the Docker file here is based on ASP.NET 4.7.2, which is backwards compatible to 4.5. It's kind of the way they've done that. And then Windows Server Core version 18.03. It's going to make this working directory, which you've probably seen from IIS, inside of the container. And then it's going to copy what's put in the Docker publish output. So kind of like you would see in the bin folder, if you were publishing to the file system, it would make like a bin release publish folder. It's going to do this, Docker, object Docker publish, really the same idea, and then use that to copy it into an IIS deployment. So I would build those, but they actually can be really slow. It's got to pull down a lot of stuff, so I'm going to skip that step for now. And this last example I've got, this is a lot of stuff, but essentially what you're doing here is if you wanted to locally have some registry, and you could even put this on a server. Say you've got some box that is on the network and other people have access to it. You don't have to go public on Docker Hub or pay Azure for registries. Just like with Git, you could git init something. This is the same concept. You tell it that you want to access that box on port 5000. You want it to restart whenever the machine restarts. Basically, with Docker, it's going to always stay on. And then you name it. And registry, this is the name. It's a little confusing, but this is the name of the container you're making, whereas this is the name of the image you're making. And so Docker actually produces an image that's the standard template for a registry. And then you could do, this is just an example of the type of stuff you could put into a registry. But at its core, this one line up top is all you need to make a registry. And this is stuff that I don't think anyone probably memorizes, but it's just a good way of seeing what the syntax looks like and knowing what kind of stuff's possible. So I guess with that, I don't know if anyone has any questions. I know I didn't get a ton into .NET, but it's definitely a bit of a beast, the Docker.
Full UI type stuff, if someone wanted to put, say, a Visual Studio Code, is that possible? Would you have to do X11, or how would you get to the full UI?
When you say full UI, do you mean like on an application level?
No, like if I install Visual Studio Code on a Docker container, could I get to that?
I see. You could. I know they have the command line options where you can use things like Chocolatey to install the package, that's just like a package manager, kind of like you may have seen Homebrew on a Mac or NPM for node modules. You can actually install software packages with something called Chocolatey. And in Windows, it's just run through PowerShell. So I've seen a lot of examples where with Windows, they'll create a Windows Server image. They'll use Chocolatey to install something like IIS or enable, like you say, Visual Studio Code. And then code has its own CLI where you can say code this. Visually speaking, you wouldn't be seeing code. You wouldn't be having like RDP access into that box. So I don't know that it'd be very beneficial in this case. As an IDE, I know you would be using it separate. So There wouldn't be much of a point to it, but in theory you could.
If you like buy, it could be used as a development environment.
Yeah. Yeah. So really you'd be developing outside of that. Now, you know, the example I gave with the CMD command prompt, you could do that and use it for testing out some Windows concepts. But really, at that point, you may be better off with the VM just for the development side of it.
Can you use Visual Studio to connect to like a project inside of the document machine? So like you can develop outside of it, but then inside of it.
Right. I know with SQL Server, that's one example they give where a lot of times you may need to communicate locally to a container to be able to talk to SQL Server. So you would essentially have a separate project running the Docker container, and it exposes a port for SQL, and then your connection string in this other application then is what's doing the talking to SQL Server. So it's not that Visual Studio is really integrating with Docker's API. It's more that Visual Studio is enabling you to run another application that then goes and talks to the box. But it's abstracted out. It's just as if you had a REST API hosted somewhere. You know, you could do that. You could have a REST API running inside of a container locally and then be hitting that as if it were a remote server. And that's kind of going into the microservices concept of what is really big right now with the cloud.
I saw in your diagram that there was a Docker-specific API tucked away down in the middle layer.
Yeah.
Is there a way you can, is it common or something that people consider if it's time to play around with the name itself within the Docker? Can you get to the API? Can you send little nudges to it
I think
outside of the actual container itself?
The CLI, like it says here, is actually using a REST API to contact it.
Right. I'm wondering if the REST API is accessible by, say, another application.
That there is a folder in the program files that's being referenced there. There's an exe, and you can contact the daemon directly. And that's something that's common in a lot of those automation scenarios where you're going to install something and you know exactly what the path of the daemon is going to be, and you can get in there and do some very low level stuff for sure. So the CLI, I would almost equate it to, and this may be a terrible example if no one's worked with it, but the Azure PowerShell API. You've got an Azure REST API, you've got an Azure PowerShell API, and you've got an Azure CLI. And behind the scenes, they're all accessing the same Azure. It's just different ways of getting to it, different layers of abstraction, you know, for different reasons. Cool. Well, we've got more pizza if anyone still wants to hang out a little longer, and appreciate everyone coming out. Yeah, I hope I didn't ramble too much. I was hoping to get a little more hands-on with the .NET side of it, because I know that wasn't the title. But I hope this was a good overview of what can be done. You know, to more just inspiration on why Docker is what it is.
So like I can now use Docker perfectly, and I will never admit to look at anything again.
Yeah.
I did a Docker online training that was way less fun than this, and it was real pizza. And afterwards, I'm like, okay, this is so simple. I got this. And so I have like an Ubuntu media server at my house, and, you know, chock full of drive and automation. And these enterprising guys have come up with a Docker alternative to plowing through all the install process. You can drop in these different media automations in different containers. I'm like, oh, perfect. This is a good project for you to start with. And, about 2 days before I hit the let's go to this meeting button, I had finally fished out my Ubuntu store thumb drive because I just totally used it. But and one of the things I thought was really cool was that once I felt like once I got all the Docker containers set up, it'd be a heck of a lot easier to manage it. It's a lot easier to disconnect one of those containers, update it, replace, rather than having to screw around with doing an apt-get and then researching on my own.
Yeah.
That was cool.
You have to know like what folder it's in. Being a Linux box, you know, going to USR or etc, var.
All of it.
Yeah.
Yeah. looks like a lot more manageable. Maybe.
You ever heard of Vagrant?
I saw a lot of comparisons to Vagrant with Docker when I was looking up stuff, but I didn't see what Vagrant was exactly.
Basically the same thing, but it's bigger.
Yeah.
It uses full like strip down images.
Now they do have something called Hyper-V image containers. I think that's the term they're using for it. And that's going down that path, I believe, where if you need a really secure environment that's not doing stuff like sharing the kernel with the host and all the lightweight efficiency type stuff, it can act a little bit more like a VM, where each one has its own full set of resources. So that's probably in response to Vagrant if they were there first.
Yeah, that's way Vagrant. They had like Docker had a hub.
Yeah.
Vagrant had that. Use when they whatever you want.
And if you develop for it, are you a Vagrant?
And you just pull it down. Yeah. And then you had to have like VirtualBox or something like that running on your machine.
Yeah.
But that was what I did a project one time where I was developing outside of Vagrant, but it would let you link like a directory from the outside to a directory inside. So whatever you put here, so that it's here, step by step.
Yeah.
It's pretty cool.
I know actually it's interesting you mentioned VirtualBox because I think Docker warns you that whenever you enable the virtualization features that are required, it makes VirtualBox not work.
Oh, really?
I haven't tested that to really see if it actually doesn't work anymore because I use VirtualBox on my Mac. But
it depends, I think. Like if you have
on Windows, I think specifically.
You have the home version of Windows, not the Pro. If you want to do Docker, you have to put VirtualBox. And then it uses VirtualBox for virtualization. Yeah. Because they don't have the Hyper-V and all that built into the home version of Windows 10. Yeah. So they use VirtualBox. You got the Pro version, then you have Hyper-V and all that.
Yeah. I'll be excited to see if eventually they could get the Windows containers onto Linux or Mac. Because I know that's I think a big hurdle for me is the Windows side actually has quite a bit more configuration than the Linux side does. The Linux side is very much plug and play. I think it's always been that way. Windows kind of locks things down a little bit. Yeah.
Put half the operating system into the firmware.
Yeah.
You can't just steal it.
You're trying to replace your head. It's a PC now.
I think I'm going to kill this meeting. You don't have to run off or anything, but I'm just...
You see a lot of examples of people using it for load testing, like this